Algebra 2. Today we're going to look at section 6.6 in your textbook. It's on function operations. I know from Algebra 1 you've looked at functions before. F of x, g of x is a common notation for those. Remember, a function is a problem where the x values do not repeat. Also, you may recall from Algebra 1 that a function's graph will always pass the vertical line test. In this section in Algebra 2, we're going to learn how to do operations, adding, subtracting, multiplying, dividing, and then after that also what's called composition, which I'll explain when we get there. Notation for the first slide. Basically, I'll give you 2, 3 functions. I'll give them names, f, g, h, I can use any letter, and I'm going to ask you to find the sum, which is the answer to the addition of those functions, or the difference, the answer to a subtraction problem. Product is the answer to a multiplication question, and quotient is the answer to a division problem. Sometimes the textbook will use notation like f plus g with parentheses around it, and then of x. That's how you pronounce that, f plus g of x. What you can do is you can separate the two functions and put a plus sign in between, which is what I prefer. F of x plus g of x. Whatever the rule is for the f function and the g function, you're going to add those together to find the sum. If you see this notation, which is f minus g of x, you're going to write that as f of x minus g of x, and that is the difference. When you see f times g of x, you're going to use the f function and multiply that by the g function. That's going to be the product. And if you see f divided by g of x, you can write it as f of x divided by g of x to find the quotient. Just be careful on this part because whatever comes first in the notation will go on top and be the numerator of your division problem. So some examples so we can make sure that we understand what we're expected to do. When you're asked to do function operations, in the directions it will clearly define the 2 rules or 3 rules that they want you to use. So for example, let f of x, and again this is the notation for a function you learned in Algebra 1, the letter f is just the name of the function. So let f of x be the rule 4 times something plus 7. Let the g function, the g of x function, stand for the rule the square root of something plus that same value. For question 1, it's asking us to find the sum of f and g. Following the letters, f comes first, you would write that down as 4x plus 7. You would then drop your add sign, bring down your g function, which is the square root of x, and then plus x. You have 4 terms right now on this line. You're going to look for like terms, just like you would any other type of problem, that's addition, and put them together. We can see that the first and last term are like terms. 4x plus 1x gives me 5x's. I'm then going to just drop down my square root of x, and then my plus 7. So my sum, my answer to the addition problem of f and g is 5x plus the square root of x plus 7. Example 2. F of x minus g of x. Again, notice that the f function is in front, so we must write the rule down in front. With subtraction, it's probably a good idea to make sure that you're using like a parentheses here or a bracket, because subtraction, remember, is a type of problem that you have to change the signs of every term behind it. So I'm going to use a bracket here and copy down my g function, which is the square root of x plus x. Then, next line, you would show the next step, 4x plus 7 subtract off the square root of x, and then change the sign of the positive x to a negative. So essentially, again, just a quick reminder, what a minus or subtraction problem does is it changes the signs of everything behind it, and I've highlighted those in blue. Next, you're looking for like terms. The ones I've underlined have the same variable and power. 4x minus 1x is 3x. You'll drop your radical term down, and then I'm going to choose to put the constant number at the end of my answer. And so this is the difference or the answer to the subtraction problem. Notice that, or how different these answers are. Okay, using the same two rules in the directions, we're now going to do question 3. -4 in front of f of x indicates that that's being multiplied. -4 times f of x plus 10 times g of x. We're going to drop down our -4 at first. We're going to multiply that, so you can use like parentheses or a bracket. Drop your rule down, which is 4x plus 7. Drop your plus 10 down, and you're going to multiply 10 by the g function. And in the directions, again, it's the square root of x plus x. Okay. All right, from here, you're going to use distributive property. So we're going to do -4 times 4x. Just basic algebra skills. -4 times the 7, -28. Then you're going to take the positive 10 and distribute it. And we've worked with radicals in the past. This is not a radicand, so you're just going to say 10 times 1. It's going to be a 10, and then drop your square root of x beside of it. And then 10 times x is 10x. Alright, next move, you're going to look for like terms. And I've got a -16x and a positive 10x that need to be combined. -16 plus 10 is -6. Drop my variable down. I have a radical term in this answer. Comes down. And then I have a constant of -28. And so that would be the answer to this particular question. It was an addition problem, but it also had multiplication involved. Okay, next I'm going to change the rules for f and g. So let me highlight these. My f rule now is x squared plus 9. And my g function rule is x plus 3. Okay, example 1 on this slide is asking us to take the f function and multiply it by the g function. So we're trying to find the product. Since it's multiplication, and since there are 2 terms in the f function, please make sure that you put parentheses around the entire quantity. That's a binomial. If you forget to use parentheses, then it's more likely you'll make a mistake. We're going to use parentheses around the g function since it also has 2 terms. And so now we're going to take a look at what we have. We've got a binomial times binomial, and we know the drill. We've got to do FOIL. First, outer, inner, and last. Okay, so that's how you would approach that question. So we'll finish this up. First would be x squared times x. That would be x to the 3rd. Outside would be x squared times 3, 3x squared. Inside would be 9 times x. And last would be positive 9 times positive 3. Notice there are 4 terms, and your goal is to look for anything that has like terms so you can combine those. Again, like terms are same variable and power. I do not see anything that looks the same. And so this would be the product of f and g if these are your rules. Okay, example 2. F of x divided by g of x. So f of x, I'm just going to rewrite this. It could be written this way as well. F of x divided by g of x. We need to put the f rule on top. So x squared plus 9 goes here. The g function becomes the denominator of this fraction or this division problem. And with division, what happens a lot of times is once you write it down, that pretty much will be your answer, especially when there's two terms on the bottom. You can't divide just x squared by x and 9 by 3 because this is a complete binomial. And so this would be the quotient. However, there is a catch to these. When you're dealing with division answers, you always want to pay attention to the denominator because there is a value. There is one number for x that would cause this part that I've highlighted to be 0. We do not want the denominator of a division problem to be 0 because we can't divide by 0. It's going to be undefined. So this entire thing I've circled can only be the answer if and only if x does not equal blank. There is one number that will cause this to be 0. Something plus 3 is 0, and that would be negative 3. So basically what this says is, this is the answer as long as x is not negative 3. If it's not negative 3, we are in good shape. So this part, all of this part, must be written down for your answer to a quotient. So again, just be really careful, pay attention to the denominator, and make sure if you do happen to have a variable in your answer, that you do make this statement. Okay, question 3. We've got 2 being multiplied by g of x divided by f of x. So this time we're going to put the 2, and we're going to use parentheses for times. The g rule is x plus 3. And then divided by the f function now goes to the bottom, and it looks like this. Okay, so that would be the answer. This would be the answer as long as the denominator is not 0. So now what you do is try to figure out, well, is there any value that I can substitute in for x to cause the denominator to be 0, thus forcing the problem or the answer to be undefined. And so, like on this one, it's probably easier to do in our head. Negative 3 plus 3 is 0, but now we're looking for something squared plus 9 that's 0. Anytime that the problem on the bottom is one that you may not be able to do quickly in your head, you can always go to the side, write it down, and then force it to equal 0 and solve. Now, if I solve this equation for x, I'm going to notice that I have a quadratic. So first of all, that means there's 2 possible answers here. But I have a plus 9. So if I'm solving this equation, I would have to transpose the 9 to the other side, and that would actually cause it to be negative 9. Well, we know from the past that when we have a quadratic equation with the power of 2, because I've taught you all about the quadratics, so you should know how to solve quadratic equations. We've done factoring, quadratic formula, we've done completing the square, we've done square roots. So always, after you learn it, make sure you apply it in any situation, okay? It doesn't necessarily have to be the section you're currently on. So that's part of this math content, is make sure you can apply what you've learned in the past and recognize it as well. So if I take the square root of both sides of this equation, I'm going to end up getting x is equal to positive negative, because there's 2 answers, but I can't do the square root of negative 9. We know that. When we type it in the calculator, it does not work, meaning we fall back on our knowledge from complex numbers. You have been taught this year. You're going to factor out negative 1 times 9. You're now going to say x is equal to positive, negative, square root of 9 is 3, square root of negative 1 is I, so it's basically imaginary. So the answer to this problem is right here that I've highlighted, but it's only true when x can't be an imaginary number. When that happens, when it's like imaginary, this part doesn't necessarily have to be written down. I'm just showing you how to get there. If it's like a real number, then I do want you to write it. If it's imaginary, most of the time the textbook won't even write it. But I did want to share with you what happens if this can't be easily done in your head and you can't figure out, well, what value of x is going to cause this to be 0. Just go to the side, show me your work, show me how you thought about it, and if you actually end up getting a real number back, then make sure that you make that statement. Alright, next content or learning target in this unit is on function composition. Composition is one of those math concepts that's always used on the ACT. They expect you to know this. There's two different ways that they can actually write it down. There's two different ways for notation. They can use two sets of parentheses, but this is how you would read it. It's not times problem. It's f of g of x. So every time I see parentheses, I'm thinking like of. F of g of x, or f of g of x. But notice in this notation, that little circle there, it's not an O. It's actually supposed to be a little bit smaller than what I have on the screen right now. It almost reminds me of a degree mark, like the symbol we use for degrees, for angles. So when you see that symbol, it stands for composition. So what we need to learn right now is, well, first, what the word means. If we don't know what it means, we won't be able to apply it. Composition is you combining two or more functions together. Composition is you combining two or more functions together. Now, what I mean by that is you're actually going to substitute one function in place of the other for x. And you're going to just basically follow notation and follow the order the letters come in. For example, if you have the rule f of x, let's keep running the time here. There we go. If you have f of x is equal to x minus 5, I'm going to highlight f of x. Here's my f of x rule. And then my g function is x to the second. Notice that the notation I've used in question 1, I decided to use the parentheses. So this says find f of g of x. Again, I want to caution you against thinking this is multiplication. You have to be extremely aware of that and very careful. Function f, I've highlighted in yellow. Function g, I've highlighted in blue. I'm going to color code to make sure that we are following. Here is how you combine f of g of x. Your job is to, whatever's in the front, basically, you're going to recopy that name. You're going to just recopy f. You're not going to start with that. You're always going to start with the inside function first, the one I've highlighted in blue. F of g of x means this. Go to your directions, find the g function, whatever it is. Again, I've highlighted it for us. Just write the function, write what the function's equal to in its place. So instead of me copying f of g of x again, I now have f of x squared because x squared is equal to g of x. Now the problem says you're going to ignore what you have here after you simplify. This is your new problem, so this is where your eyes need to be. Find f of x squared. What that means is go to your f function. Again, follow the name. Go to your f function, which is here in the directions, and where this is called the input. This is what you're going to input into your function, and you're going to input it in place of x. So I can give you a number here, I can give you a letter, a binomial, anything. It could be given to you in parentheses. Whatever is in parentheses is your input into your function. You are going to substitute this in place of x in your f function. So we're ready to now do that. Once we get to this step, you are no longer dropping this f down. This is only there to show you which function to use. Go to your f function, put x squared in x's place. I would write x squared. And then the function says something minus 5, I would put minus 5. And so x squared minus 5 is a problem that obviously cannot be simplified because there's no like terms. So we're dealing with x squared minus 5 as a binomial answer. That would be the composition of f of g of x. Okay, now we're going to use the same two functions, but look at question 2. I have switched the order of the name. I put the g function in front and the f function on the inside. Please notice the notation because, again, I'm going to be really picky on how you write this down. You have to, whatever the letter is in front, you must write in your first step. And you can do it to the side like I'm doing. You're going to draw your parentheses. Now you're going to look, your eyes are on the inside function. It's the f function. You're going to go to your directions. You're going to see what f of x stands for, which is this part, x minus 5. That's what you're going to substitute in those parentheses. Okay. Underneath it, straight underneath, you're going to drop your equal sign. G is only there for you to follow the direction, like which function to use. This is now saying go to your g function in your directions. Your g rule is something squared. This part in the parentheses, whatever you are given, is what you substitute in place of x as you write it down. So mine says x squared. That means I'm going to write x minus 5. And then I'm going to have to square it, but I'm going to show that outside the parentheses. So all of this has to be squared. And we know from the past, because we've done this multiple times this year, if it's a binomial squared, you're going to have to write it down twice and use the FOIL method. Okay, so your answer for question 2 will not be exactly the same as question 1 because we're combining the functions in a different order. For this one, you would get first x to the second. Outside would be negative 5x. Inside would be negative 5x. And last would be positive 25. You would then look for like terms. The two in the middle look the same. You would then, and I'm going to bring this up here, you would write x to the second minus 10x plus 25. And so this would be the composition of g of f of x. Here's my answer for question 2. Please notice how different these answers are. Question 3. On number 3, again, I'll highlight so we can follow our lettering. This says find f of g of negative 7. Find f of g of negative 7. We are doing composition. We are combining two functions together. This time, however, instead of me just giving you an x or g of x or f of x, I've actually put a number here. You are going to follow the same exact pattern. You're going to look for the first letter. You're going to recopy to the side. You're going to draw your set of parentheses. You're now going to go to the g function in your directions. It says something squared. This time, though, the something is not just x. It's not me just copying this down. It's me saying negative 7 goes in place of x. So I'm going to say something squared. So f of negative 7 squared. Okay, now I'm going to have to simplify that a little bit. It needs it. Negative 7 squared is the same thing as negative 7 times negative 7, which is positive 49. So recap on question 3 one more time. This says find f of g of negative 7. You copy down your first letter. You go to your g function, the inside rule. The inside rule is g x squared. Instead of writing x squared, you put negative 7 in place of x. You actually square 7. You get 49. Next step, notice there's only one single letter left. Again, that's just the name of the function. It's now asking you to go to your directions, find the f rule, which is x minus 5, something minus 5. Whatever's inside parentheses is what you substitute in place of x. So you're going to write 49 minus 5. And then answer it. You're going to end up getting a number back. Every time you see a number on the inside of the parentheses, like the innermost parentheses, you would expect to be able to give me a number answer back. Every time you see just like a variable or an expression, expect to give a expression answer back. Okay, we'll try number 4 now. Number 4, the G is in front this time. The F is on the inside with the 100. Alright, so we are going to start the same way we started the first 3. You're copying down the first letter, drawing your parentheses, and then you're keeping your eyes on the inside. F of 100 means go up here to the F function, something minus 5. Instead of writing x minus 5 here, you're going to put 100 in x's place. 100 minus 5. And do I need to show that step? Yes, I want to see that you've actually looked in the right location in your directions. You're then going to simplify. 100 minus 5 is 95. And you're now looking at a problem where the only thing I have left is the g function. And so this is telling me, go to your g rule in your directions. The g rule is something squared. My something is 95. So I take 95, I square it, and that should give me the number answer for that value, or for that problem. 95 times 95 is 9,025. And so that is my answer. Okay, alright, so next slide. I'm changing it up on you. I've now created 3 functions. The f function is 1/2 x squared. The g function is 12 minus 6x. The h function is x to the 3rd. Okay, question number 1. We have f of g of x. Okay, so I gave you 3 rules in your directions. In question 1, I'm only using 2 of them. We follow what we see. First, we copy down f, we drop our parentheses, we go to the green function in the directions. It's equal to 12 minus 6x. We write in 12 minus 6x. Our eyes are not on this now. Here's our new problem. We go to the yellow function highlighted. The rule is 1/2 something squared. I write down 1/2. I leave room for my something, and then I square it. And that something is right above. I drop 12 minus 6x. Alright, next step. We have multiplication here. We have an exponent. You're following PEMDAS always in these types of situations. You are going to notice that the inside is actually a binomial, which means it needs to be written down twice. And then you're going to use FOIL method, and then take half of your answer. Okay, so in this problem, I'm going to kind of cut this one short because I know you know how to do this. You can do it in any order, but the way I worded it a second ago, you could do FOIL here, first, outer, inner, last, figure out what that is, and then whatever answer you get here, then you're going to multiply every term by 1/2. Okay? All right, let's move to 2. Look at 2. I had g of x. G of x. G of x. Okay, everything's green now. We're going to copy down our first letter, G. Parentheses, we're going to go up here, grab our rule, 12 minus 6x. Okay. Now, this is our new problem. Go to the G function, where you see x right here. You're supposed to put all of this stuff in its place. So we're using this function again. 12 minus 6 times something. 12 minus 6 times something. We drop it down. Okay. To simplify this, we do not subtract before we multiply. So we're going to distribute the -6. We're going to drop this 12 down for now. -6 times 12 is -72. -6 times -6 is positive 36x. You're going to combine your 12 minus 72 to get -60 plus 36x. And so that would be the answer to that particular composition problem. -60 plus 36x. Okay, and these problems can get longer. I could have said like g of f of x, or do f of g of h of x. You just follow the same pattern and do one step at a time. Let's try number 3. Number 3 has a g function and f function. So following my kind of highlights there means I go to the g function, I copy it down, copy the letter down, or the name. I go to my directions and I work inside the function first. My directions for f is 1/2 x squared. So I copy that down. This is my new question. So now my eyes are on this part. I'm going to drop my equal underneath. I'm going to go to my g function. You're not going to copy the g down. You're ready to use it. So we're going to go 12 minus 6 times blank. 12 minus 6 times, and then you'll bring that down. And you'll simplify using algebra skills, which you have. Drop your 12. -6 times 1/2 is -3. Drop your x squared. Obviously, these are not like terms, so that has to be the answer. Okay, now let's use the last one. Grab my highlighter, got h in front. Got the f of x function going on the inside. We're going to bring down our h first. Parentheses. Yellow function, 1/2 x squared. Copy it down. There's my new problem. Ready to use the h function. The h function is something cubed. It's telling me this is what goes in place of x. So I'm going to write 1/2 x squared. At the end, it's cubed. So a big power of 3 on the outside. And you can use power rule. 1/2 to the third power is 1/2 times 1/2 times 1/2. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. X squared to the third, we're going to square or multiply it. So when you have a power raised to a power, you multiply the powers, so that should be x to the 6th, and we are done. 1/8 x to the 6th is that answer. Okay, so you'll notice I've done several examples with you. This is called composition. Huge, huge concept for Algebra 2. It is always on the ACT. You've noticed I've used this the entire day on this slide, on this note video. I really didn't use the other, but I do want you to know that sometimes the ACT does that. They'll use this little notation here, like that. That still means composition. Okay, so if you see this, you can change it over and write it like we've been doing today. Whatever comes first, you'll write down, and then write it with 2 sets of parentheses. This means the same thing. Also be really, really careful, because you also in this section, I've taught you how to do the multiplication, okay? And a lot of times, I used a star, but a lot of times the textbook will just use like a little dot. So you got to be extremely careful. The difference between this and a multiplication problem is basically, is the dot closed or open? If it is typed like this, those two problems mean totally different things. Okay, so again, be very, very, very careful. This one means multiplication, whereas this one means composition. Okay, so basically look at the circle. If it's open, it's composition. If it's closed, it's multiplication. Alright, so learning targets today, again, were I can take functions, no matter what I'm given. I can add them, subtract them, multiply them, divide them, and now I can compose them or do composition.